So what is the need of face detections? So nowadays, you know that AI become very popular. AI is nothing but artificial intelligence, where the machines can able to think and process like human beings. Human beings have the natural ability to see the pictures and recognize what is there in the picture. When you see when human beings saw a human picture, they'll see this is face and this is body, so this is eyes. So the humans can able to see the objects there in the pictures. They can able to recognize naturally. But as for machines, we need to train them. One of the algorithms or one of the algorithms that we used for face detection is OpenCV. OpenCV is nothing but open source computer vision. It is mainly used for computer vision applications. So whenever you want to use some of the face detections or object detections, face recognitions, any kind of applications, object tracking, so we will use OpenCV. So that is nothing but a library functions that is open source that we can use. So with that note, we will start our plan of attack. So what we are going to learn in this workshop is face detection with Haar cascade and OpenCV. So one of the algorithm, most popular used algorithm is Haar cascade algorithm in the OpenCV library. And the second one is histogram oriented gradient. The library function is dlib. And the third one is CNN, that comes under deep learning convolution neural network. And the library function is dlib. So we are going to see all the library functions that we are using for face detections or object detections, and the various algorithms Haar cascade, HOG, and CNN. These are the different types of algorithms that we are using for face detection, and we are going to compare the performance of this. So first of all, you can see some of the pictures here. So this is a picture that will be used for traffic analysis. Nowadays, automation is applied in the uh, tracking the vehicles. So there will be a smart camera will be there. It will capture the vehicles and number plate, and it can recognize the person. Okay, so for that we are using AI in that field also. And you can see another picture here. This picture is nothing but a group of people sitting there, and our algorithm can able to identify their eyes, identify their face. Okay, here also some of the pictures, it can identify the persons. Nowadays you can see in the mobile phone also, when you capture some of the you can take and use the camera on the mobile phone, because there are all AI enabled cameras are coming now, or the cameras are using uh, OpenCV libraries or algorithms. So what they are actually doing is, they are when you focus a picture, if there is a person, automatically the face will be detected if you take any digital cameras nowadays. So what application they are, what algorithm they are using is any one of these algorithms. Maybe they use R cascade or HOG or CNN with the help of OpenCV, dlib, etc. So we are going to practically see how we can do this. First, we will discuss about face detection with Haar cascade and OpenCV. Before that, we will see what is a image. Image consists of pixels. So pixels are the basic information of the images. Many may know that. So your image has been converted into pixels actually, uh, are made up of pixels. There will be rows. This is rows and these are columns. Okay, so this is a typical smiley image. It's a image. In that image, this consists of rows and columns. You can see there is rows and there is columns. Each block is called as pixels. So each block is called as pixels. So what is the pixel is? Pixel has the information, least possible information. So our body is made up of cells, isn't it? Similarly, the images are made up of pixels. Each pixels contains information. So that is the uh, basic thing about pixels. Next, if you take this image, it has 32 rows and 32 columns. Since it is a color image, it has three planes. One is RGB. If you take any color image, it has three planes. One is R for red, G for green, B for blue, and it has 32 rows and 32 columns. So that means how many pixels? 32 cross 32 is 1024 pixels. Actually 1024 informations are there, and each image has three planes, isn't it? Each pixel has three planes. That means into 3 it comes around 3072 information. So this simple image contains 3000 pixels. In the case of grayscale, so this is color image, you can convert that into grayscale. If you go to the grayscale, there will be no RGB planes. You will have only one plane. So in grayscale, you have around 1000 pixels. The same image in the in the form of RGB color form, it has 3000 pixels. So there are two types of images. One is color image and grayscale. Color image has RGB planes in that. So that means it has more information. Next, we will discuss about Haar cascade classifier. What is the use of Haar cascade first? So you can see lot of faces in this images. All are images. This is one image, second image, third image. All are faces. The aim of Haar cascade classifier is, what we are going to do is we need to find out the faces in the images. There will be a lot of images. It has to detect the faces in the images. That is our aim. And here you can see some of the images that doesn't have faces in it. So the image that has faces is called positive image, and the image that doesn't have any faces, human faces, are called negative images. So your Haar cascade classifier is going to classify whether the image has face or not. If the image has face, we can say it is a positive images, and if the image doesn't have face, it will classified as negative images. With that, this Haar cascade classifier, what it going to use is it going to use AdaBoost training. What is this AdaBoost? In AI, there is a subset called machine learning and deep learning. In the machine learning, there you have lots of algorithms like linear regression, logistic regression, KNN. There is a lots of classification algorithms are there. So one of the algorithm is AdaBoost. We are not going to discuss about AdaBoost training because we are focusing on the face detection. We are not focusing on how it is doing. We will use the algorithms that is already available to build the face detection. Okay, so the algorithm that we are using is AdaBoost. If you are interested, you can go through that AdaBoost algorithm. Okay, what is the use of this AdaBoost algorithm is it will generate it will do the feature selection. For example, if you take any faces, your face has eyes, nose, lips, ears. So these are the main features of the face. So this AdaBoost algorithm, what it's going to do is it generates a feature selection. So you can see here lots of square boxes here. So what this represents is it will identify the features on the faces. So there is lots of features on the faces. That features will be identified by this AdaBoost algorithm. Okay, so you can see there is a black and white box here. Okay, I will tell you what this will do. So actually, this is nothing but feature selection, feature selection blocks. Finally, we will have the face detected on the images. We will see how it is happening in the Haar cascade. Okay. Now we can see this is a popular image. You know that in an image processing they will use this Lena image. This is it is a 24 cross 24 image basically. So it is comes around 160 combinations in images. Okay. Now we will see. So these are the features. So these features will be applied to this image one by one in the form of sliding window. So each pixel we will apply this feature. Okay, one by one after another for all the 24 cross 24. So what this feature selection will do is it will do the sum of white pixels minus sum of black pixels actually. So uh, it will do this mathematical operations for every pixels. So similarly, if we apply this feature selection, it will do the same process. That is nothing but sum of white pixels minus sum of black pixels, and it will do that mathematical operations. If we apply this pixels, it will do that mathematical operations. So similarly, we will apply all the feature selections for the image. Okay, so now we can see this one. This has one here black and here also black and white and white. When we apply this, we can identify the eyes, isn't it? So it's look like a eyes. So like that, for every feature, you can apply this for nose. Okay, so they will have the lots of feature selection and they will apply this on the images. When you train the algorithm, this is the thing that will happen. The output will be numbers. You will have the numbers like this: 2, 3, 5, 6. Okay, so there will be things like that. So that means nothing but you have a 2 means out of 10, 2 are black pixels and 8 are white pixels. So like that. So there will be some combinations of mathematics. So basically, we are applying these features on the images. So here is an example. Here you can see. So this feature identifies the eyes and the forehead. Okay, this is forehead. This is forehead, and you can see the identification of eyes. So based on this, we can able to identify the feature. So it is a long process. We will not see that, but when you apply this algorithm Haar cascade, what it will do is it will uh, pass the feature selections on the images one by one for all the pixels, and it calculates the uh, uh, white pixels minus black pixels, and finally it will find out any features of the face will be there in the images or not. Okay, so this is the image and we are applying the feature 1, feature 2, feature 3, feature 4. So like that you have lots of features, and the combination of this will give you whether the image has face or not. If there is a face, it will it here you will have the face is detected. If there is no face, there will be no detection of faces. So that is the working of cascade classifier coding part. So this cascades is nothing but different types of Haar cascade that we're going to work on today, and the images, different sets of images that we are going to work. And finally, one more file is there, that is nothing but interactive Python notebook file. So that is the file that we use for Google Colab. If you click this file, So before using this file, just copy all those things on your Google Drive. So go to your browser. In that browser, you can see these dots like this, and go to Drive. So you have Home, My Drive. In that My Drive, you just copy that, and if you click this, you have File Upload, Folder Upload, File Upload is there, Folder Upload, and then upload the folder. I already have that in my drive, so it is asking that. Okay, so that is the way you have to do it. After uploaded, if you just click on your drive, you can see the images folder. You can see cascade. So this is nothing but the XML file. It is for front, eye, full body, clocks, and cars to identify. I've explained about Haar cascade. Haar cascade is nothing but uh, the algorithm that uses AdaBoost for selecting the features of the faces, or if you say eye, it will select the feature of the eye. If you take full body, it selects the features of the it will identify the features of the full body, clocks, cars, whatever the things that you want to detect, you can program that. Okay, so these are the default programs that is already trained program that is already available. If you click on that, you can see there is an XML file. Okay, so these are the files that is already there. You can download it. So you can see there is some license agreement. This is for open source computer vision library. So there is a lots of library functions available in OpenCV. Okay, we are using that. That's all. And you can see there is some of the license things, and you can see OpenCV storage. So there is some coding part. So I said no. So basically, it is nothing but passing the feature selections on each and every pixels. So what the feature selection will do, it will identifies the white pixels and the pixels in the white area and the pixels in the black area, and it will subtract it. So that is what mentioned here. So it is white pixels and it is black pixel. It will find the difference between the two. So why they are doing this in the Haar cascade is to identify the variations in the images. Okay, from the variations we can able to identify the features. So there is lots of uh, feature selections. Okay, that simple shapes. Okay, so this is basically the program. So we are going to use already available program here. It's a library function. So your folder contains Haar cascade program library functions, and one more file is there that is called computer vision masterclass face detection. This is the coding part. So we are interested in this. Okay, just click that. It will be opened on the Google Colab. Okay, so you will have a IPYNB file that is opened on the Google Colab. You can see here collab research google.com. So if you want to use the Google Colab, other than this, you just type it Google Colab on the Google. So here you can see collab.google. So you just, if you click on this, it will ask you open Colab or new notebook. So if you want to do your um, artificial intelligence or any machine learning, deep learning programs using this Google Collaboratory, you can just click it new notebook. A new IPYNB file is created. Okay, you can see IPYNB file. You can rename it and you can use it. Okay. So here you can see if you want to create new notebook or open the already existing notebook that I send to your folder. Okay, you can save or you can download it in the form of .py as well as in the form of interactive Python notebook. So that is nothing but this. Why it is called interactive Python notebook is it has text as well as code. So if you have text, you can just type it hello. So it will be acting as a text field. If you want some coding means you can type some coding out here. So that's why it is very interactive. Okay. And you have runtime, you can run all or you can run a part of the selections like this. If you have some code here, for example, import CV2. What is that import CV2 is? CV2 is the computer vision library function that is there in the Google server. So you no need to install the CV2 file externally in Google Colab. It is already there in the server. What you have to do is you have to just connect here, click that connecting, it just connected with your server. You can see some connection over here. Once it is connected, if you run it, it is a part of the running. What the tick mark says that your notebook now has the CV2. That is nothing but computer vision library. So this is how you can work on the Google Colab. So just close it. Now you will